With the swiftness and precision of a skilled mathematician, the creation of imaginary numbers rose from the depths of the abstract world to prove its practical application, seizing moments of eureka. A journey of discovery that unfolded bit by bit, planting the seeds that would eventually bloom as the bedrock of many mathematical models and formulas. Significant mathematical progress was made during the 16th century with the invention of negative numbers, often referred to as imaginary numbers. Despite their distant connection to real-world problems, these numbers played a crucial role in the advancement of mathematics. They even found use in the field of electrical engineering, where imaginary numbers were used to describe alternating current. The often perplexing concept of the imaginary unit, represented by the letter I, might appear fantastic at first sight. Its very name, imaginary, is a clue to its unconventional nature. However, it's important to note that these numbers, while abstract in nature, hold a very concrete place in the mathematical universe. Many phenomena, from financial modeling to signal processing, couldn't be adequately described without them. Imaginary numbers are often best understood through their interaction with real numbers, creating complex numbers. These complex numbers provide a useful and concise way to represent many types of quantities, such as physical phenomena and geometric relationships. By understanding and maximizing the use of imaginary numbers, these abstract concepts became important to understand and describe concrete, real-world ideas. Using the combined power of real and imaginary numbers, mathematicians developed powerful tools for solving equations and understanding the world around us. The mathematical space these numbers represent, called the complex plane, plays a crucial role in analyzing and decoding signals in fields like communications and spectroscopy. Through fascinating leaps and bounds, these abstract concepts made tangible impacts on real-world applications. In dynamic systems like those used in control theory, complex numbers also play a critical, real-world role. These systems might be electrical circuits, mechanical contrivances, or even economic policies. The dynamics of these systems can be analyzed with the aid of complex numbers. Capturing the mechanisms of such diverse fields, these numbers have proven to be both real and invaluable. The use of imaginary numbers is defined by profoundly subjective and theoretical concepts that transcend mere numerical interpretation. For example, the mathematical model might only have real solutions, yet it can be profoundly impacted by the use of complex numbers. Even if these numbers do not exist as physical entities, the effect they yield through models is very real and vital. Throughout history, the innovative usage of these abstract entities proves the power of blurred lines between theoretical requirement and practical application. Arguably, the perceived conceptual leap to understanding the value of these numbers helped make even significant real-world progress in various technical disciplines. The power of imaginary numbers is not only evident in the present technological world but also played a significant role in the realm of aesthetics. For example, in the exploration of fractal geometry, imaginary numbers created shapes never before seen or imagined, sparking new opportunities for artists seeking to represent the complex beauty of the natural world. As we peer into the depths of statistical mechanics, we find another area where mathematics and physics converge with extraordinary results. Quantum mechanics, a theory that elegantly captures the behavior of particles at the subatomic level, relies heavily on the mathematics of complex numbers. Despite its abstract nature, complex algebra has come to be regarded as the heart of modern physics. Cartesian coordinates, the well-known xy-plane, evolved into the complex plane with imaginary numbers, providing an expanded framework for geometric analysis. And improvised perspectives opened up practical opportunities in a multitude of fields, from the understanding of 3D graphics to geographical location mapping. The development of imaginary numbers serves as a tangible testament, proving that theories once considered strictly theoretical have innumerable practical applications. Their importance isn't just to solve equations. These numbers have helped to envision new worlds, model physical phenomena, develop cutting-edge technologies, and guide philosophical discussions. Today, as we step into the realm of quantum computing, imaginary numbers continue to reshape our world. Quantum bits, or qubits for short, are dependent on complex numbers to represent and manipulate their state. The power of such computation holds the potential to transform many fields, from cryptography to artificial intelligence. Progress in any field is often characterized by steps that appear illogical or abstract. Yet, collapsing these frameworks of understanding in the pursuit of new knowledge often generates revolutionary insights. The invention and acceptance of imaginary numbers is a shining example of how illogical ideas sometimes play an essential role in the fabrication of logical results. The resilience of these numbers has led to widespread applications, from quantum physics to probability to signal processing. They provide an intriguing thread that weaves together different branches of mathematics, showing the interconnectedness of abstract and concrete ideas. They have shown us that boundary-pushing ideas often lead to boundary-pushing solutions. We live in a world where the most abstract of concepts find wide-reaching applications. Imaginary numbers, those seemingly nonsensical entities, show us how beneficial it can be to break conventions and look at problems through fresh eyes. They have earned their place in lucrative corners of our intellectual landscape, gracefully shifting the trajectories of progress in different fields. This quest for understanding, propelled by the spirit of invention, instructs us on the ever-enduring nature of curiosity and the transformative powers that spring from it. Leaving geocentric models and epicycles of the past, we oscillate on the line that separates physical interpretation and theoretical postulation, exploring new realms of mathematical consciousness. The significance of understanding imaginary numbers lies in both theoretical reasoning and practical application. By adapting our perspectives to harness the potentials of the unknown, we step into a future paved with revolutionary ideas and technologies. The value of such conceptual exploration cannot be overstated in our quest to unravel the mysteries of the universe. In reflection, it's fascinating to contemplate the relationship between imaginary numbers and our perception of reality. The existence of these abstract entities and the grounding into practical applications demonstrate a duality of reality, encouraging a profound and deeper examination of perceived facts and phenomena. The mastery of imaginary numbers has had a profound impact on our lives, combining intuition and formal logic to devise transformative technological breakthroughs, mapping the landscape of complex systems, and fostering novel artistic expressions. They serve as a reminder of the power of human thought and the potential it holds to mold a dramatically different future. Over the centuries, mathematicians like René Descartes, Carl Friedrich Gauss, John Arbuthnot, and many others broke the mold to affirm the validity and importance of imaginary numbers in igniting and driving advances across numerous fronts. The future holds uncharted territories for harnessing their potential as we journey toward continuous scientific and technological growth. It's quite astounding to realize how the imaginary came to hold such real and significant power in our world. A testament to the fusion of logic and creativity, these spectral numbers have demonstrated the synergistic power of abstract thinking and pragmatic application, forging paths toward unprecedented exploration and discovery, both in the mathematical realm and beyond. As we move towards greater understanding and exploration of our universe, we can be sure that the role of imaginary numbers will continue to expand. Which complete system can seamlessly unite the theory and practice, the abstract and the concrete, much as complex numbers have done in the past few centuries, remains a challenge for the mathematician of tomorrow. So, as we dwell on these enigmatic entities and their profound implications, we realize the importance of embracing the unknown and continuously pushing the boundaries of our human understanding. Who knows, the next abstract concept we regard with skepticism today might be the breakthrough that transforms our world tomorrow. Imaginary numbers, a testament to the sublime beauty and mystique of mathematics, offer us an elevated perspective of the world. These ethereal concepts nudged our species into a brave new world of understanding and application. And it is through adopting a similar view toward the unknown in general that we might hope to fruitfully progress as a people. As we venture further into the 21st century and beyond, continuing to integrate the theoretical beauty of complex algebra with its real-world utility will be a continual challenge and triumph for mathematicians, scientists, engineers, philosophers, and artists alike. It will require us to respect the wisdom of the past and harness the power of our collective innovation to uncover new understanding from the unknown. Ultimately, the invention of imaginary numbers, rather than transformations or paradoxes, should be viewed as expansions of our current understanding rooted in practical applications. As with any tool, these numbers can be used for profound good when wielded with the intent of illuminating and clarifying rather than distorting and misleading. Imaginary numbers inspire awe and humility, for they remind us of the inexhaustible richness of the mathematical universe and our humble position as mere explorers of a grand, cosmic spectacle. Let us continue to grasp the nettle and explore the abstract as an access point to deeper expanses of understanding. The story of imaginary numbers doesn't end with their invention. It is a vibrant, continuing saga of exploration, innovation, and breaking down barriers of understanding. They serve as a beacon illuminating the path leading to further discovery, proving that in the mysterious dance of the universe, even seemingly paradoxical numbers have a role to play. Let us remember that abstract mathematical inventions like imaginary numbers, although they may appear meaningless at face value, could well underpin the very fabric of our technological advancement. Their invention highlights the fruitful struggle between the known and the unknown, the abstract and the real, and the interlocking dance of these elements defining our continued exploration and understanding. In conclusion, the faithful service of imaginary numbers in enriching our lives and expanding the frontiers of human knowledge is enormous. They stand as an inspiring reminder that any aspect of reality can be transformed by the prowess of human ingenuity, paving the way for prospective revolutions in science, technology, and virtually every other sphere of human existence. The importance of imaginary numbers cannot be overstated. They aren't just part of the scaffolding that upholds modern civilization's scientific edifice, but the engineers and architects of our infinite curiosity and innovative spirit. They have been and will continue to be a bridge, connecting the known and the unknown, the visible and the invisible, the real and the imaginary. Our study and understanding of these numbers beautifully encapsulate the essence of human progress. As we continually push the frontiers of our comprehension, we forge the links necessary to connect seemingly disparate corners of knowledge. As we delve into the mysteries of the seemingly imaginary, we create pathways leading to solutions and discoveries that revolutionize our world. It may be ironic that a term like imaginary stands solidly anywhere, let alone in the hallowed halls of mathematical significance. But then, as we push the frontiers of our knowledge, the familiar falls away to reveal a more profound understanding of what is possible when we are brave and curious enough to explore that we don't even yet understand.